Okay, here's your review for your 6 weeks exam. What I went ahead and did was put some notes to each problem, facts that you need to know and be able to recognize. I will walk you through that, and if you need some more assistance. And we're going to also put some slides to help you make sure you can identify the type of problem and what skill you need to use to solve it. So, we have a tangent. The tangent is a line segment that touches only on one side. It will never go through the circle. So that is our tangent, the 7.2. And we have a radius. The radius goes from the center to the circumference of the circle or to the edge of the circle. That is this right here. This is our radius. This is what we're trying to find. That's where the question mark was. Whenever you have a tangent intersect or meet at the radius, it will always be perpendicular. And so that box will not be given to you. You're supposed to know that fact. You'll be able to see a tangent, recognize it on a circle, and then see if it touches the radius, and if it does, it's perpendicular. So you have to go straight to a squared plus b squared equals c squared. So if you understand tangent, perpendicular to the radius, we're going to do Pythagorean theorem. So from here, we should just be plugging in our a's and our b's. We can have 7.2 squared plus our radius squared is equal to our hypotenuse, which is always opposite the right angle, 9.7 squared. And we're gonna actually take the square or square decimals. If you're not too sure, we just literally just type in the 7.2. The square button is over here by this 4 button, and then we hit enter. We're gonna put the whole decimal down. We're not gonna round it. Okay. So our 7.2 squared is 51.84 plus our radius squared, r squared, equals, and when we do 9.7 squared, we get 94.09. And now we need to solve for r, so we're going to have to subtract the 51.84. Get the radius squared by itself. And when I subtract that, we get 42.25. And then to solve for r, we're now going to need you to take the square root of both sides. So now, let me scroll up a little bit. Our radius, which is what we're trying to find, is equal to 6.5. And that's our answer. So you're definitely going to see this picture on your slideshow. We're going to just give you different pictures, different types of problems, see if you can recognize what to do for that problem. And then over here, we have congruent tangents, or aka cone head. Whenever you have a tangent coming from the same point, for example, I'm going to look at this tangent 8 right here. It's coming from this point on the outside of the circle. It touches the circle only once. It's showing that point of intersection. Well, the tangent across from it is also coming from the same point. So it kind of forms a little cone head. Well, those two tangents are going to be congruent. That's why they're called congruent tangent, or aka cone head, because if this is 8, then this little piece over here, that tangent over there is also 8. And if you kind of, I wish I could kind of rotate this, but I can't, but you can kind of see the little cone head form. If I would have gone this way, you have a little cone head on the top. All right, so when we see cone heads, or if you see a circle inside of a triangle, we're going to use congruent tangents relationship, meaning they're going to be equal. And we're going to use that to find the missing tangents, because over here, that is a tangent, that is a tangent, they're both from the same point. These two tangents are also going to be congruent. So to get the length of my red tangents, I'm going to have to take that 14.4 minus the 8, because I know the whole segment is the 14.4, and that remaining part is going to be 6.4. Well, that's going to be that's going to be 6.4 for the other tangent. Now I can find the remaining tangent on this part by subtracting that 6.4 from 14.2. This will give me 7.8, which means this tangent over here would also be 7.8. And now I can do the perimeter, because you're going to be asked to find the perimeter of each polygon. Well, to find the perimeter, that is the distance around the triangle. We have to add up all the sides. Well, I already have the 14.4. I know that's this side. I also have the 14.2. I know that's the left side. So I need to go ahead and add my 7.8 and my 8 to get 15.8 to get the third remaining side. And the perimeter, our distance around 14.2 plus the 14.4 plus the 15.8. Go straight to your calculator, type it in, and get that our perimeter is 44. All right, so our first page here is basically dealing with segment relationships, understanding tangents, also understanding secants. What I've put to the next to each problem is the key relationship, or what you need to recognize and the rule that goes with it. On 3 and 4, 3 we have a secant. A secant is a line segment that comes from the external, from the outside of a circle, and goes through an inner circle at 2 points. Okay, 2 points right there. So we have 2 secants here. They're not the same length. They're coming from the same point, but they're not the same measurement. Well, the secant rule says you take what's on the outside, multiply to what the whole secant. This means you're going to have to add here, add the parts. Okay? And you take what's on the outside, multiply it to the whole secant. Again, we got to add the parts. All right, so I'm just going to abbreviate this. To do outside hole, that's ow, or whoa, if you want to do it in the opposite direction. But it's easy if you start with the outside. So outside I have the 6. I'm going to come here. I'm going to now add the parts. This is going to be 6 plus x is equal to what's on the outside of my green secant, which is 7. It's going to be multiplied to the whole one by adding the parts. That's 7 plus 11. Now I know you can probably do that mentally, but we're just going to simplify. I'm just going to take this, what I have here, and simplify it down here. So what we have is 6, parentheses 6 plus x, sorry about that, is equal to 7 times 18. Okay, the whole segment is 18. So I know you can probably, if they have numbers, you can just mentally do that part. But make sure you recognize you are going to have to distribute. And then now we're going to solve the equation for x. So this is 36. So 6 times 6 is 36 plus 6x equals, and then 7 times 8 is 126. And then to solve for x, this is where we can't have algebra errors. You need to kind of maybe practice solving equations, but some of you have this down locked. So subtract your 36, isolate our variable, we get 6x equals, we got 126 minus our 36, that's going to give me 90, and then we divide by 6, and x equals 15. So you're definitely going to see a secant. Over here we have an inscribed angle. They want us to find the measure of the arc or angle indicated. So an inscribed angle, you might want to add this, please, because you need to be able to know how to identify it. Basically, inscribed angle is an angle with vertex on the circle. I'm just going to abbreviate circle. There's your symbol for circle. Okay, on our circle test, I asked you to understand the relationship when it's at the center, when it's on the circle, when it's inside the circle, maybe in the interior but not at the center, and the outside. We're just going to really focus on inscribed angles because there's several properties that go with this. So vertex is on the circle, this D here, that vertex is on the circle. We're going to find the measure of that angle, FDE. Now, the rule is, let's add this, the inscribed angle is, I'm not sure if y'all remember the rule, half the intercepted arc, okay? Half intercepted arc. Now, some people struggle visually of understanding what intercepted arc means. My angle has 2 sides. They're usually rays or chords. Our sides are FD, this side here, and DE. Now, if I was to extend this side, and I don't want to go into my definition, but if I extend this side, the curve that's inside, in between those sides, that's what we call our intercepted arc. So here, I'm going to kind of highlight it in red. This is the intercepted arc for inscribed angle FDE. So the measure of that angle is half the arc that's inside of it, okay, in between them. So I know the arc is 130, so our missing angle, the measure of angle FDE, is going to equal to 1/2 of the 130. So basically, FDE is 65, yes. Measure of angle FDE equals 65 degrees. Okay? And the other segment relationships with circles is number 5, chord. Whenever we have chords intersecting, segments intersecting inside a circle, and it says, I know it says, assume that lines that appear tangent are tangent. Okay, we have no tangents here. Don't let that confuse you. I'm sorry, I didn't read the directions first, but I want you to just be able to look at a circle, look at a picture, look at a problem, and recognize what's the relationship, what to do for that problem. So for chord, X is inside. It's going to be part times part equals part times part. I have A times B equals C times D. Basically, take a chord. I'm going to start with my chord that has the X. The parts for that chord are X and 10. So X times 10, that could be like the A times the B. X times 10 is going to equal to the other chord and its parts. The parts for the remaining chord, the other chord, is 8 and 15. So we're going to add those together. So I can simplify it. X times 10 is 10x. And we can do 8 times 15 is 120. And then we're going to solve for x. Just divide by 10. So x is 120. Okay, so you're going to definitely see a chord. So that takes care of that page. If you didn't need any assistance with this page, or as I go through the review, if you got it down, you can just fast forward and go to the type of problems that you need help with. I'm probably going to try to go a page at a time. But there's the first video. Thank you.